do the recording for them. So first I want to say thank you everybody here on the call live and everybody watching the recording for your flexibility and understanding of the very last minute change to your schedules last week when we did not have this session, and then like the quick turnaround to get us all here by Monday. I just really appreciate all of, yes, as I said, the understanding and the flexibility. Last week was a wild ride. My partner is doing better. He is now recovering from concussion and shoulder surgery and all the pieces. And hopefully we are just fully in healing mode because I leave on Wednesday and his dad's coming into town. So I'm handing over care duties. But thank you so much for all of your patience. So we are talking about describing and analyzing patterns tonight, and I'm super excited because this is, I maybe say this every time, but I do really enjoy this session, and I have no idea what you're looking at now that I am trying to pull up the screen. Let's see if I can get this up and rolling for you all. Nope, of course not. There we go. Okay. Now it's working on my side. Can I get it to work on your side? So we are describing and analyzing patterns and what that looks like for all of our students at different ages. And so we're going to play Charty Party. If you have not played your Charty Party yet, you'll get to see how it goes. For those that have played Charty Party, I'm super excited to hear how it has gone with your students and different things. And then we're going to talk a bit about kind of like what's actually going on inside of our students' heads as they are looking at patterns and thinking about patterns, and what's going on in all of our brains and how we can use that, how we can sort of leverage that to our advantage to go through some strategies with our students. So good old Charty Party. These come from the purple box, which you all should have received a couple months ago. Very unannounced to your schools. I think you've got a couple versions of it. How many have played? Has anyone played with their students yet? No, Patricia, this one's a little hard for you because it's not really kindergarten appropriate. Okay, some of you have. Awesome, but some of you haven't. Okay, for those that haven't, Charty Parties like Apples to Apples or Cards Against Humanity. So I'm going to give you a graph like this one, for example. And then you are going to, I'll give you some options for the y-axis because you might notice that there is no y-axis labeled here. So a couple things to point out, the y-axis increases as we go up. So we're in the top right-hand quadrant of the like 4 quadrants of graphing for all of our math folks. So we're in the top right-hand quadrant. The y-axis goes up as we go up the screen. The x-axis increases as we go off to the right. In this graph, we're looking at organization level that ranges from backpack full of random papers level of organization to color-coded notes organization. There's no y-axis, as I mentioned, but what you need to do is look at the y-axis options and then vote for which you think would be best that would result in these data as it relates to organization level. Hopefully that makes sense. Let's roll through the first round and see how it goes. So your options for the y-axis, and you can kind of vote in we'll just vote in the Zoom chat so we can see what everybody's voting for here, are 1, height of hands in the air being waved like you just don't care. 2, belief you could win a cooking show competition. 3, depth you fit your arm into a vending machine. 4, how long you'll search for something before giving up. And 5, the inability to speak in an indoor voice. I don't want to scream at you all through Zoom. So 1 through 5, what do you think, put it in the Zoom chat, would be the best option for the y-axis here as it relates to organization level to give us this data pattern? Love it, love it, love it. Okay, we got some 4s, some 5s, some 4. Ooh, lots of 4s, but some 3s. Excellent. Carrie, you want to jump in and explain why you chose 4?
Because I liked that one because I will not give up when I'm searching for something. And so it seemed like an appropriate answer.
Awesome. So you're speaking from some personal experience here, Carrie, is what I'm hearing is you're like you were drawn to number four. Awesome.
Yeah.
Jameson, were you thinking something similar when you were picking number four, or was there something else you were going off of?
I was kind of going off of organizational level, just the
Mm,
title, connecting those two. I mean, I liked 3 and 5 and thinking of my middle school students. I like
mm-hmm.
that a lot, pairing that with them and just kind of being like an outside of the box thinking of sorry, my words have not been coming to me today very well. Of
It's Monday.
correlation. That's what I'm looking for. Like an outside the box idea of correlation with them. But I went with closer to related with just the more organized you are, the less likely you are to be losing something. And no, like if I don't find it in these 3 places, it's gone.
Got it.
Or
Got it. So I'm hearing a couple different things, Jameson and Carrie, as you guys are talking. It's like sort of what you're drawn towards, some personal experience, maybe some lived experience, either yourself or with your students in terms of their organization level, things like that. Awesome. Okay. So same thing, but here's round two. So now we're looking at days of the week. We've got our good old bar chart that our students love. Days of the week, and our options now for the y-axis are lateness of bedtime, usefulness of a bicycle, amount of consecutive winky faces sent over text, ounces of ketchup you'll put on hot dogs, and likelihood your friends have to quietly apologize for your behavior. Ooh, I love it. All sorts of different questions. Ooh, 1, 5, 3, 1, 1, 1, 1, 1. Awesome. Excellent. Okay. Maisie, can you jump in and explain why you chose one? And then Patricia, I'm coming to you for number three.
Yeah, if I'm reading it right. So the y-axis is larger values towards the top. So I assumed you'd be getting to bed later on the weekend.
Mm-hmm.
Not quite as late on Sunday, but still later than you would during the week.
Mm-hmm.
But that would probably be for an adult, not a youth.
Okay. So you're like, there's both kind of the like, this makes sense, and maybe I've lived through this as an adult, and this maybe not is what is the reality for my students that are
Sure.
coming into class. Excellent. Okay. And Patricia, why'd you pick three?
I just figured like teenagers on their phones because winky faces is that means they're up to no good.
Excellent, excellent. So we're pulling a lot from sort of our lived experiences, our lives, our knowledge of context of different things. Let's just do one more, and then I want to hear from those that have used it with your students, how it has gone, and then I'll explain kind of why we sent Charty Party to all of you. So here we're looking at grades, and then the options are likelihood you just text back K, weirdness of haircut, how attractive you think you look in a vest, odds that you'll stain your shirt, or likelihood your friends have to quietly apologize for your behavior. What are we thinking for this one? All right, so we got some. Oh my goodness. 1, 2, 4, and 5. We almost have all 5 covered with this one. I love it. Excellent. Okay, so one of the things that I love about Charty Party in the way that you can like playing it this way is that we don't all have to have the same answer. And that is really fun and a great opportunity for our students. But before I explain a little bit more of sort of why we sent you Charty Party and what opportunities it affords our students when they're practicing describe and analyzing patterns, those that have opened the box, have used it with their students, would someone be willing to kind of jump in and explain a little bit of how it went or what you did, things like that? Yeah, Carrie.
I had some extra time one class period with my agriculture kids, and so I just pulled it out and I gave them, they had already been playing the watershed game. And so I kept them in their groups and just gave them Charty Party and said, okay, just see what you can do. And they opened the box and they read through some of the directions. And for the middle school kids, they really weren't understanding that it was just kind of a game and it was for fun, and they were like, none of this makes sense to us. And I said, okay, well, true, but you could read the directions. And then they tried reading the directions and they still tried playing. And so once they kind of figured out that it wasn't a competition or that it wasn't something that really needed to be analyzed, it was more for fun, then they kind of got better at it. But it was definitely a learning curve for them because they instantly thought, oh, this is like a test. There's supposed to be a right answer. And I was like, no, there's actually not. But it was good. It was good for them to have something like that because they're always trying to find an exact answer and analyze it. And with that, it's just like fun to do.
I love it. What a fun way to sort of push them out of that comfort zone in a low floor way, right? I mean, sort because we're always trying to be like, well, what do you think? And how does it make sense to you? But just, yeah, it's just a game. Play a game. Awesome. Thanks for sharing, Carrie. Have others? I thought there was sort of maybe one other hand or head nod. Stacy, how did it go with you?
I did it with my high school leadership class when we had an extra few minutes. And I told them it was like Cards Against Humanity. So they were all like, yeah, yeah, yeah. They got on to me because I kept laughing at all the things because they were all hilarious to me. And they're like, you don't know how to play right, Miss Stacy. You always smile. And I'm like, because they were trying to guess which one went with who. So yeah, I have no poker face. So they all laughed at that. But it was really interesting to see how they interpreted some information. And then some of the other things that were like, well, that doesn't make any sense. So it was interesting for those kids to play that, and we just getting started with it. They liked it so much. These are cool high schoolers, right? So cool. They were like, oh, can we play that again? So that's the best part.
That is a good part. Yes, we always love it when they want to do something again. Excellent. Andrea, have you used it? Did I?
No, I have not. My coworker Liana has, and she said they had fun with it, but I didn't get more detail from her. I haven't personally yet.
Yeah, awesome. So a couple of the reasons why I love it and why we wanted to share it with you all are things that Stacy and Carrie have brought up. It sort of creates opportunities for different kinds of conversations. When it comes to, okay, so Patricia, stick with us for a second because I'll come back to like what this could mean for your kindergartners. For our middle school and high school students who are looking at two variable axes, like all Charty Party graphs have two variables. And so it's sort of why I keep being like, not for kindergarten, because we don't yet have two variables in our graphs in kindergarten. But for our middle school students who are just newbies to looking at two variables, and our high school students who in theory should be good at it because they've been looking at it for a couple of years, it's a fun, different way to get at the skill of looking at data, thinking about patterns, thinking about how the different variables relate to each other or correlate, as Jameson was saying, right? Like that correlation between them. But in a really different, I'm pausing for a second, in a really different capacity than we typically have them look at it. In our content, for our curriculum, for our content learning objectives, usually there is an answer. Carrie, as you're saying, like they so think that there's an answer that we're going for. Like typically there often is one that we're trying to kind of get them to with data. And so this kind of flips the script for them and it takes away one of the axes, like totally one of the axes. The other thing I love about it is that it's not a super like number perfect line based, and that kind of throws them off a little bit. It's a little bit different. I think of this as like we do pull-ups, we do push-ups, we do bicep curls, but it's a different way to get our students practicing and working with analyzing and interpreting data. And there are so many different ways you can run it. And so the way we just did it, where we were all looking at the same graph, and then we had different options that we could choose from. Or if I'm in person with folks, I'll be like, okay, we're all going to look at the same graph, and different groups have different options to choose from. And then there is a little bit of a competition because it's like, who has the best y-axis? And best can be it makes the most sense in the real world, or best can be it's the funniest, but you can explain why that relates to it. Or you can do it like, well, it sounds like Stacy was running it more like Cards Against Humanity and Apples to Apples, where you're trying to guess like who put in the different y-axes. So there's a bunch of different ways and iterations that you can go with it, and it doesn't have to take a huge amount of time. So if that doesn't resonate and if you don't like it, no hurt feelings. But it was a game that came about. So they produced, you all have the purple box, they produced the orange box. And then teachers contacted the company and said, please, 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 we need more options that we can use with our students in our classrooms because this game is so awesome. So they created the all ages purple edition. So you can imagine what is in the non-all ages edition. Even the purple box, there are some that I do not allow out into the game when I'm working with students, depending on who the students are, type of thing. And so I also think it's a company that we like supporting, which is why we had them send you guys the games, because they listened to teachers of what teachers were wanting for their classrooms. And I just think that's awesome. And I wish more companies did that. And so that's a little bit of a backstory of like why these games arrived for you all at your schools, and sort of piecing apart some of the components. Ideas, thoughts, questions about why we shared them, how you can use this, how this might relate to your students? Okay, not hearing any. Patricia, you can play with this one. We can jam on it. Maisie, I'll come to you in a second. We can jam on it on how to do it with just one variable for your students, where they're sort of, the pattern is there, and then they're thinking about what the variable is on the bottom. So the box in and of itself, how it arrived for you, doesn't work so great for our younger elementary students, but upper elementary or middle school students, it works with. But that's a way to transition it. And I would say ChatGPT has been one of like, this is a really good use of ChatGPT, is to get them to like produce different like them, it, whatever pronoun we use for this thing, to get them to produce some graphs and some possible axis options. I found like really quickly within sort of 10-15 minutes have been able to get a set to work with some of the early elementary teachers we're working with in other places. And so we can do that and bring it in April if it's of interest to you or things like that.
Awesome. Thank you. Yeah, because I'm also taking an AI course online. So that's great.
Perfect. Yes, yes, yes. Okay, Maisie, what were you going to say?
I like that it really zooms in on, that it really highlights the y-axis, and it forces you to think about what does the lower end of the y-axis versus the higher end mean, that you really have to come to grips with that. So that was it's a nice feature of it.
And it's fun because it has scatter plots, line graphs, bar charts. I think those are the three most common. And they're all different kinds of patterns show up in the data. And so that's nice as well, that you can sort of filter it out or pick which graph types you're wanting your students to play with and look at, and different things like that. So enjoy. If that resonates for you, enjoy. It is one of the strategies that I did want to share that we're going to be talking about as a way to help your students think about and kind of build out this muscle better of describing and analyzing the pattern, which is to adjust the way they are seeing the data, or adjust the way you're having your students practice the skill of data analysis, of just looking at what is on the page, which is different than interpretation and drawing conclusions, which we talked about in November and December, of so what does it mean in the broader context, and what could we therefore say, and what projections could we make off of the graph based on what we learned. So here we're just like, what's actually on the page? What do we see? How does it relate to the y-axis increasing or decreasing, or the x-axis, or what are our different categories that we're looking at? Sort of creating other avenues, other opportunities for them to practice that is a great strategy to use for our students, sort of changing things up a bit for them to create new opportunities. So we are here describing, analyzing patterns in terms of all the range of things that we could be doing with our students with data. And as I mentioned, this relates to what we were talking about in November and December. For those that joined that call, the recording's in there if you were not able to join and you want to go back and look at what we were talking about. But sort of how do we set our students up for success with making a claim or drawing a conclusion or doing that interpretation of our data? Similar but slightly different. When we think about our soccer analogy that we've been using throughout, sort of what does this look like in soccer? This thing that we're trying to talk about is when it shows up in data is the describe, analyze patterns is when we like break down the components of the game and we practice them over and over and over again in practice to build up sort of that muscle memory, that foot memory in soccer of, oh, this is how we put together plays and how we connect all these different pieces together. And so it's not the full execution, it's not of the game in soccer, but it's all those pieces that come together. We got to know those pieces to effectively pull it together in the game. We have to know what's actually on the page in our data visualizations and how to look at what's on the page or on the screen before we can interpret what it means, make a prediction, infer from it. We got to actually see what's there, what's on the page. So we're going to think about like what's going on inside of their heads. Like what actually do they see? We as humans seek meaning and try to make connections. It might not feel that way all the time with your students, but I swear, as humans, this is what we're trying to do. And I'm showing you this map of Australia because when I first saw this map a couple years ago, I was like, wow, my geography is really bad. I thought the middle of Australia was mostly a desert, but there are these huge rivers going through the middle of Australia. Because for me, in my mind, in the split second, I was like, oh, blue squiggly things over land are rivers, because that's what I've seen on so many other maps that I have looked at. I was seeking meaning, I was trying to make connections, like you all were making connections with the charity party to like personal experience and understanding of the context. So I didn't even read the legend that said the dark blue are natural gas pipelines and the light blue are liquid pipelines. I was just jumping to that seeking meaning. I was looking at it and sort of jumping forward. And we're going to talk through like, why is that the case? And then therefore, like, if that's what we as humans do, how can we kind of flip that to our advantage to help our students? So we're going to jump into breakout rooms, and each breakout room is going to have one set of visualizations to look at. So breakout room 1, you're going to look at the line graph. Breakout room 2, you're going to look at this bar chart. Breakout room 3, you're going to look at these pie charts. And what I want you guys to do in the breakout rooms is just look at your visualization or visualizations and think about what patterns do you see, and then what patterns might your learners see if you were to hand them this visualization, recognizing that the likelihood of this content area and this style of visualization actually being in your curriculum might be pretty low, but like just hypothetically think, if you were to bring this to your students tomorrow as a bell ringer, like what patterns do you think would jump out at them? So you can get to this through our shared resource document. We are here on page 36 is breakout room 1, breakout room 2 is on page 37, and then breakout room 3, you're down on page 38. And so I've got the questions in for each of you, for each of the breakout rooms there. So just what patterns do you see? What patterns would your learners see? And let me, I'm just going to do some random breakout rooms for this first conversation. So get in, chat with one another. You should be able to, I'll make sure you guys can share screen if that's helpful. Are we good? Everybody have a sense of what's going on? Okay, have fun. Welcome back, welcome back. Excellent. So thanks for playing along so that we could have a like common experience to talk about and think about as we are doing these different pieces, as we're sort of jumping in to thinking about what's going on for our students inside their heads and different pieces like that. So I know the data might not have been totally relevant, but it gave us some opportunities to look at different kinds of data visualizations and talk with one another. Any sort of insights or thoughts as you guys were talking through what you saw and then shifting to talk about what you thought your learners would see if you had shared that with them? Yeah, easy.
Well, we had the Taylor Swift one. And
Okay.
so our first thought was our students would say Taylor Swift helps the Chiefs win games. So we assumed it would go straight to that. But
Yeah.
it was interesting that the game she went to, there was I think there was a more than 40-point score. So it did go some of the scores did go quite high, whether that was causation or correlation or who knows what.
Yeah, but I loved how you would say what you're talking about there is like, but they would go to causation, right? I mean, that's sort of what I'm hearing. It's like they would be like, oh, well, it's higher when yes, Taylor Swift was there, so therefore da 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 da. You know, they would jump to that filling in the blanks piece. Awesome. Other thoughts as you guys were reflecting on kind of what you would see or what you're seeing and pay attention to versus what you think your students would see and pay attention to that folks want to mention beyond sort of that like jumping to one particular conclusion that may or may not be supported in the data? Yeah, Patricia.
So one of ours was like frozen fresh water. And so for me, I was thinking like, okay, there's a difference between like, I was thinking like ice cubes in the freezer. And it's just kind of like defining some of these things first and thinking about it like outside the box, besides just out in nature or wherever, just kind of broadening like, okay, where could that be?
Yeah, sort of providing some like context around it because their lived experience might be really different than what the data visualization is showing or trying to get them to. Awesome. One thing I noticed is that a lot of what you guys were putting in of like things your students would notice were had to do with like the colors or some like I liked it that group Patricia that you were in breakout room 3 was like it looks like Pac-Man, right? Just sort of like the literal physical like what are we visually looking at were some of the things that you guys were commenting on that your students would be picking up on. And this relates strongly to this thing called our visual, like a hierarchy of how we visually process information. And this is true for all of us that are able to see. We have these different stages of visual processing. So this starts at the bottom. So the very first thing that we need to do is we need to recognize or register that there is visual input. This is a really interesting thing to be talking about. I had not even processed as someone who has lived for the last 9 days with someone with a concussion. It's like reliving all the visual input in a really different way than he had prior to his concussion. So you have to register that there is visual input. For those of us that are visually able to see, we recognize like the light and the color and the shapes that are coming towards us. Our eyes cue into that. We do this without even realizing it until you have a concussion, and then you could become very aware of how much your eyes are doing. And then we have this step that in sort of this model of visual processing, they call pattern recognition. I just want to call this out. Like this is different than how we're going to talk about pattern as it relates to data. Here it's talking about like, oh, it is round, or it is square, or it is long. That is the type of pattern of like, I've seen round things before. I've seen square things before. Because your brain, as you're processing all that visual information in, it's taking in and it's making sense of it. This is what little babies do like all the time, is they're just like forever looking around. And so we create that, I've seen this before. I can categorize it into this pattern that I have seen previously. The next step up is us engaging with that. So those mental models that we have put together in our brain and sort of pulling from the memory of, I've seen this round thing before. I've seen this white, yellow round thing before in the sky. I can connect that with this other round yellow thing in the sky that I have seen previously. And then we get to the next order of visual cognition. We're like, yellow round thing, yellow white round thing in the sky is the sun. And we're processing that visual information in. Now, this just took me minutes to explain. What those of us that are visually able do within like milliseconds. Like we don't even realize that this is what is happening as our eyes take in visual information and as we connect in with our brain of like getting that interplay going back and forth. A lot of what we were calling out that our students are working on is down here. It's in the like registration and pattern recognition of the visual information. And a lot of the things that you all were talking about as you were saying, you know, like where's there's the most land and the least, or looking at sort of the lowest lows and the highest highs, or that mass increases, so does volume. We're up here, we're sitting up here in visual cognition. We are recognized what the visual input is. We see the pattern. We're pulling from our memory of other times when we've worked with data like that. And we are moving into the cognition, into the making meaning of it. So how do we help our students who are sitting more down here move up here into visual cognition? And part of it is I'm going to say like an example that has nothing to do with data, and then I will come back to the data. So when we learn to read, regardless of what age you are, when we learn to read, we go through all of these steps because reading is actually visual processing of information, which we all know, but just sort of saying that out loud. When we're like literally reading from the text. So understanding that we have letters is part of registering this visual information. You can go into like any nursery school or preschool, or Patricia might even have these up on her wall of like super colorful letters with like pictures alongside of things that start with that letter. This is helping us just get into that. I'm recognizing the visual input. I'm recognizing that we have letters. Then we move up to pattern recognition when it comes to reading letters. And those of us that are dyslexic, this is where it gets really hard for us. But for everybody else, like we all have to learn that this is the J, not this, not this, not this, not the other direction, as I always used to draw my J's. And that this is the M and this is the W, that the orientation of these shapes, of these visual things that we're seeing matters. And then we take it up to the next step of pulling that together to read the word of jam. And oftentimes we put another visual cue next to the word, especially as we're just starting out, just learning to read. So we don't jump into Harry Potter. We start with easier words and sounding them out in different components. So I am in no way suggesting that reading is only about these visual things, but I just wanted to take this example of reading and sort of break it out on these in this visual processing, the hierarchy of it, because it relates to how our students make sense of data. Because there are common data patterns that show up when we are working with data. So let me show the patterns and then I'll come back to this slide. So a very common pattern that shows up, we call it different things. This, y'all, is where life with data gets really tricky in the K-12 space because we call the same thing by different names across our different subject areas and across our grade bands. So this pattern of as one thing increases, the other thing increases, or we have more across different categories, increasing, ascending, positive, direct. We have lots of names that we call this pattern, but this is a pattern. The corollary is decreasing, descending, negative, indirect, that we call it, where as one thing increases, the other decreases, or we have less of the categories. This is only relevant if our categories are organized in something that is relevant to what we're asking, but we can do it in categorical and numerical data. So we have increasing, we have decreasing. We also have one of the common patterns that shows up in our spaces when we're working with data is a stable pattern. Our students sometimes call this no pattern, but actually It is a pattern. It's just that it's stable. So that as one thing is increasing or changing, the other one is not increasing or changing too much. So that's stable, juxtaposed with variable, where as one thing changes, the other thing changes, and it does not seem to matter, like which direction it goes. Or our categories, the values that we've observed are just sort of all over the place across those categories. There's like no, this is where it's like, well, there's no real discernible, like identifiable pattern that we could point to. So we call it variable. It's just sort of, it just varies a lot. And then the final one, especially for our older students that shows up, is cyclical. Sometimes we call this seasonal, like here, if you were like specifically looking at carbon dioxide, I mean, over time, you could call this seasonal. It has to do with the seasons, but we see cyclical patterns in physics that have nothing to do with the seasons or with time. But there's just this cadence of up and down that happens consistently across. So these are like 5 common patterns. Almost every time kids are looking at data in our K-12 system, it's one of these 5. Cyclical, variable, where there's no or no pattern, or it's just totally variable. Stable, which is different. That's why we can't call this one no pattern. Decreasing or increasing. So we have these 5 common patterns. This is what we often are sort of pointing towards and looking for when we are talking about data in our science or our social studies curriculum. But I want to go back to this because this is how there's a difference between how we talk about patterns in our math classes, especially for our older students in their math classes, where we're talking about what's the fit. The pattern becomes sort of our functional fit of the data that's going on. In here, in this case, we're using the word pattern to mean different things. So here, we use different words to mean the same thing. Here, math science, we both use the word pattern, and we're talking about different parts of the data that we're wanting our students to cue into. So I shared this not to say this is wrong or we shouldn't do this, but just to help us as the facilitators of their learning kind of have that background context, that understanding of like, oh, how they might be talking about pattern in math class might be different than how they're showing up and I'm asking them to talk about it in science, or vice versa, things like that. And so us knowing that allows us to either talk to our colleagues, some of them are here in the cohort with us, or those that are not in our cohort, to be like, hey, how are you talking about it? Or hey, when are you getting to these things, as a way to make it easier for us as they're coming into our spaces. So there's 2 things going on here. One, there's kind of the vocabulary that we use, and then there's 2, getting them to have a sense of like, do they know the base pattern? Do they know the equivalent of the letters when they're looking at data, when we're asking them to describe it, analyze it, and then move on to interpret and make meaning of it? Okay, so we each work in different places. So I want to give us an opportunity to kind of each think for a few minutes of like, reflect on our own curriculum, what might be showing up in our own curriculum that we've taught thus far this year, or that you know is coming up in the subsequent units that you have between now and the end of the year. And think about, of these patterns we just talked about, which show up for you, and then which of your students, like which of those patterns would your students just know? Like if you put a graph up tomorrow morning as a bell ringer for your students, they would absolutely knock it out of the park. And so I've put a space in our shared resource document for us to capture some of these ideas down. And so this is down, sorry, don't mean to make you dizzy, on the bottom of page 38. So Patricia holds it all. So we've got elementary here, but then if you're science or math, just like grab a spot, doesn't matter what age level you work with, but just sort of what's showing up in your curriculum and what do your students know off the bat, or vice versa. If you were to show them it tomorrow morning as a bell ringer, It would be like deer in the headlights is what you would see out of them. So let's take a few minutes to each do some individual reflection, and then we'll come back together and sort of talk about these patterns before we take a break, because we've almost been going for an hour now. Excellent. Okay. So I want to open it up before we take a break for, sort of walk away from our computers for a few minutes. Are there any questions that are coming up about these common patterns, or about this thinking about like what's at the base level, and do they have that base level of understanding before we're asking them to do cognition? Let's start with questions, and then I'll shift to what are some things that are resonating or jumping out at folks. Are there any questions about what we've been talking about so far? Yeah, easy.
So the cyclical or seasonal pattern, it looked to me, it was reminding me of trigonomic, so sine and cosine patterns. Is that accurate? Are
Mhm.
those
Yep.
okay? And
Yep.
does that overlap with stable? Because it's stably between two values on the y-axis as the x is increasing. Because there was also in the stable examples, one of them looked similar to a sine cosine pattern.
Yeah, that's a really interesting point. And so this is where it gets into like teasing out, like sometimes there's really one, like if we actually look at the full Mauna Loa pattern, it has both a cyclical, Mauna Loa is the observatory in Hawaii that we've been recording carbon dioxide on. I just want to make sure when I say this, like if this actually means something. It's the very characteristic like of carbon dioxide increasing over the last couple of decades. So Maisie, that's a great example of like it has a cyclical pattern and a positive or direct or an increasing pattern relationship at the same time in the same data set. And so with the sine cosine, like, yes, if it's, it is pretty stable because it's just going to be within the same range. And so you could talk about it as being stable, but it's typically the up and down, the consistent up and down with a periodicity that we're interested in when we're exploring that sine or cosine pattern, like function to it. And so it kind of gets at like, well, what angle are we taking? What do we want to talk about? Very often people talk about the Mauna Loa graph as this positive pattern of over time carbon dioxide is increased. Great, except there's also this really cool cyclical pattern of basically like the earth breathing as as the plants bloom in the northern hemisphere and then in the southern hemisphere, you can see this great relationship with respiration and of the plants across our different hemispheres and different things. Photosynthesis, sorry, not respiration. And so it kind of gets at like, what are you going for is which one you would potentially want to focus on, or both. You can have both within the same data set. Did that help?
Yeah, no, that was really helpful.
Okay. Great question. Other questions that are coming up for folks as you guys are kind of thinking about looking at from this perspective of kind of like, what's the base pattern or the base thing that we might be asking our students to see and describe as they're analyzing data? Okay, hearing none. Are there any ahas or connections or things that are resonating as we're talking through this and as you were thinking about how this relates to your own curriculum that folks would like to bring up for the full group before we take our break? Always a hard thing. Like, it's okay. We'll take our break no matter what. Yeah, Andrew.
I think this is really helpful. I like making anchor charts and, and it helps kids give like a really tangible tool that they can like plug and play. And I've needed the common language to be able to use to like give them something that makes them feel empowered a little bit. So just giving them 5 words that give them the language to talk about data is something I haven't really had before. I've only really had positive, negative, and constant or something like that. But it's this is giving me a little bit more confidence to be able to teach them with a really concrete strategy that will help them pick apart data a bit better.
Awesome. Excellent. Patricia, I realized I was going to put in the resource document, and I'll do it during break, what the equivalent words are for our elementary students. Because these patterns that we were talking through, like, not many of these like fit for your students, but what the words are for elementary, I'll put inside the resource document. Sorry, I didn't get that done before we jumped on.
Thank you. Yeah, I was thinking like my pattern is, I don't know.
Excellent. Okay, let's take a break. Let's come back we'll get going at 8 after. Does that seem good? Like 8 minutes to walk away from the screen and take a break, get food, water, whatever you need. Okay, awesome. So see you in 8 minutes. Thanks all. I'm not sure when I missed pressing record again, so I will go back and look at the recording and make sure how much of that is there for everybody else. Welcome back, welcome back. As we get started again. Stacy, you were nodding as we were heading into break. Did you find sort of this way of thinking about the sort of core root pattern helpful for your students?
Well, I realized that I didn't talk enough about cylindrical patterns.
Cyclical, yeah.
Because I do teach about cycles, but I never thought about them with graphs. So I need to make sure that I go back through and I'm talking to them about the graphical doing that with that. So that's just something on me. And the randomized data we kind of get and talk about, we talk about increasing and decreasing, but as far as that cyclical pattern,
Mm-hmm.
think about it with a graph. So that's a
Yeah.
very good one. And I like your example of in Hawaii there too. That's perfect. That's right up our alley in astronomy. So perfect.
Perfect. Excellent. Yeah, astronomy is a fun one because there's so many, right? We're all on orbits and all the things. But then if we actually sort of pull it out into that
Mhm.
two-dimensional space and I mean, so I was an oceanographer originally, a marine biologist. And so I always am like, oh, the tides. That's actually like how you take the round moon orbit and then understand the tides.
That's right.
See,
That's right. You're
see how
absolutely
these
correct.
two cross together. Excellent.
Yes.
Fantastic. Well, okay. Welcome back, everybody. I am excited to sort of jump into okay, so if those are our core, so if one of our takeaways is making sure kids in essence understand the letters, that they can actually kind of read the shape of the patterns that we are seeing in our visualizations at any one time. So we can kind of a takeaway of what we can do for our students is that we can do this gut check and we can have them think of, or like we can get a sense of like, do they know the pattern that is showing up in our data that we are asking them to work with and make sense of? This is where I'm going to say, math colleagues, you all do this really well, like better than those of us in science and social studies do sometimes. We're like exploring we're exploring the quadratic function or things like that. And so then they can see that and they get really used to it. But having that understanding of like, do they even know what to look for before we're asking them to look for it can be a really good strategy to take as we're thinking about, we want them to get to that visual cognition, but we can't get there unless we have a firm understanding and a firm grounding in what are even the things I'm supposed to be recognizing in the visual input that is coming in. So how we move them from that pattern recognition up to visual cognition. And we do that over time, that builds up that visual memory piece so they can move faster into that visual cognition the way all of us could as we were looking at those visualizations. The next chunk of things that I wanted to sort of explore and play with are like, okay, so how can we help them see it better? There's a like, do they know it? And then even sometimes when they know it, it is hard for them to see what we are trying to get them to see in those patterns. So we're going to explore some strategies on how to do that. Before I get there, there's a lot on the slide. I know there's a lot on the slide. We're not going to like dive too deeply into it, but what I really want you all to take away is that we are experts. Even if you don't feel like an expert, you are an expert when it comes to working with and making sense of data, looking at the visualizations that are in your curriculum, the different data sets and things like that. And so as an expert, we think and see things differently than we do when we're a novice, and our students are still novices. This is true for when we're working with data. It is true when we are learning any new skill, so a sport or content area or a musical instrument or a new hobby. Our brain processes information differently when we're a novice versus when we're an expert. But this has big implications when it comes to our students working with data and making sense of data. As an expert, we notice features and meaningful patterns. That's what Jameson earlier, you were like, well, that correlate, what's the word correlation, right? Sorry, it's a Monday. I too am struggling with my words. We see that. So we see this is a funky graph. This is latitude. So this is down by North Carolina and this is up by New Jersey. This fish, this funky fish called the black sea bass, it's the central latitude of where we have found it from the 1960s to the 2010s. It trekked north, like the whole group, the whole population moved north. This is not a like seasonal migration of it like went north and then it came back south. Like the whole population has shifted north. We see that as that meaningful, like, oh, what's going on? Why would this whole population move north? Our novices see this and they're like, it goes up and down. And they're like literally focused on the surface attributes, the peaks and the valleys. So we physically see things different. and our brains process things different when we're an expert and a novice. So I just want to share that with you as like one layer of what's going on as your students are working on it. If you guys want to talk about this more, I'm happy to stay after and talk about this more, or we can totally nerd out about it in April when I'm there. But I just wanted to call this out of like, it's different. Like what you see and what they see on the page is different. It's also, oh, interesting. I'm not sure why that showed up so strangely. Just a second. As humans, irrespective of if you're a novice or an expert, as humans, there's some things that we see better than others. Like we're really good at seeing positive or increasing patterns. In fact, we like sometimes see them when they're not there. We can have the exact same mathematical relationship between the data points, but it is a negative or it is a decreasing pattern, and it's harder for our eyes and our brains to pick it up in a data set. So I just share this as a like, if in your curriculum you have a lot of decreasing or negative patterns in the data, like what we were just talking about, just know it's going to take your students an extra minute or an extra moment to catch up, because just our brain, I mean, it's a fascinating sociology thing as to like why, or psychology, like why our brains see positive increasing more than we see negative decreasing, but that's a whole separate issue. But just to share as well, like this is another layer of what's going on for our students when we're asking them to make sense of data and patterns. Okay, so if that's what's going on, what are some things we can do? Highlighting is your friend. Annotations are your friend. We often do this when our students are reading prose, like they learn how to actively annotate, actively read prose, and we can bring that in to our work with data to get their eyes cueing into different things. So this isn't just like willy-nilly highlighting or annotating different parts of the graph. It's sort of setting them up to be strategic. Either we do the annotations or we teach them to do the annotations, because we're going to leverage how our brain and our eyes process the visual information. So let me give some examples first. Okay, we're going to like go back to the land of elementary students. We're just gonna like start with some basic data here. And Patricia, maybe some of this looks, can sort of resonates with things that you're looking at. So we have our line plot, our dot plot, and we have the heights of our different students in our class, maybe for our number of inches. Okay, so we can sort of things that we are seeing. What are some things that pop out to you all when we're looking at these data? Anything you guys notice or would call out as a feature of the data or a part of the pattern of the data? Yeah, go for it. Just jump in. I can't see you all.
There's a big break off. 50 and 51 are, I guess, outliers.
Okay. So big break off, I heard you say. So it's like these are sort of not like the others. It sort of reminds me of the Sesame Street. Like one of these things is not like the other. So these are really different. So we could add a line that sort of really showcases that like, oh, those are much lower than the others. We could also circle them to be like, these have a really different shape to their circle than if we were to do just 49, or we could extend this to 48 and 49. So it's similar along that number line that we have. So these are two examples of annotations that we could add onto the graph that create another visual cue for our students' eyes to look at. They could do it as well if they wanted to. I'll explain what all of this is on the side in just a few minutes. But let me give you another example. Okay, again, simple bar chart. They love those bar charts. Somebody besides Maisie, what's something that you notice in this bar chart of the number of goals that Alex, Cindy, Jack, and Reggie scored in their hockey games?
I noticed that the lines are every 2 goals.
Nice. Okay, so we're cueing into like the spacing of the scale here. The arrow probably was having students check out that as well, Mickey. Love it. Excellent. Anything about kind of a pattern of what we're seeing across these 4 students? Or anything that's kind of jumping out as different, more than, less than? Go for it. Yep.
There's kind of a false, because the names are alphabetical, there's a false overall shape suggested by the heights of the graphs. Like they don't actually have any relation to each other necessarily.
Yeah.
It's all individual data.
Great point, right? Because each of these are individual kids that were on the team that were playing hockey. And so previously, when I was talking about how we can see our patterns of increasing, decreasing, cyclical across our categorical data, and I said, if we've organized those categories in ways that are relevant. So Maisie, great job picking up that like these are organized alphabetically. Might that be important? Maybe. I don't really know why having your name at the beginning or the end of the alphabet would influence how many scores, how many goals you scored in a hockey game. But for example, organizing the months by the months of the year might actually be a really good way to do it, as opposed to organizing it alphabetically. Like chronologically, the months might be better than alphabetizing our months. So paying attention to how we organize those categories can be helpful. Let's say we were trying to get students to think about kind of like above, like they had at least 10 goals. Well, you could kind of put a line at that 10 to cue them into this is where I want you to pay attention. I'm not saying you would, but this would be a way to annotate that attention in, or you could sort of circle everything above that 10 or below the 10 to get that across. Again, it sort of reminds me of Maisie when we were talking about like, is it stable or is it cyclical when we're talking cosine? Well, depends on what we're trying to do with it. And so these annotations can create a way that we can drive attention in. Many of us don't only work with bar charts in the count type of category. This is very similar. This is very much where our elementary students lie, of like how many are in each category, and that creates our bar charts. Oftentimes, those of us in middle school and high school, we're looking at an average. This is like huge averages. So we're looking at cumulative carbon dioxide from China, Russia, and the United States. And we often are looking at like, okay, so here's a bar chart of averages. A different way to help students make sense of this difference across China, Russia, and United States, which again, you have to think about sort of the order of the categories, but also like, okay, so what are we looking at the scaling? Well, if we actually plot out all the raw data, one, it kind of gives us a better sense of the full range, and sort of those big differences between the bars get a little bit smaller because we're actually looking at all of the data that went into those averages. So that could be a way that you kind of give your students information to look at. The annotating would be if you're going to want to circle all those data. So kind of similar to those of you that were looking at the Taylor Swift, but rather than just plotting the raw data over those average bars, you'd want to kind of put a circle around it. Give that visual cue for your eye to come in. Okay, so why am I spending so much time being like, annotate? Well, it has to do with Gestalt principles. Have any of you heard of Gestalt principles? Patricia?
Well, I mean, I was a psych major in college, so I just know that name.
Okay. Has anybody heard the word Gestalt, or Gestalt is sometimes also how it's pronounced? Like the Gestalt, it's like zeitgeist. It's like a word that sort of seems to be like popping up a bit. Okay, so the Gestalt principles were a set of psychologists in the 1800s in Germany and Austria. And Kristen is not a psychologist and I'm not a neuroscientist. This is a really fun session as I'm like trying to explain all of this like neuroscience, brain science, visual science into what does it actually mean for our students. So they were trying to figure out like those of us that are visually able, basically in Kristen speak, how do our brains not implode? Like how do we go about our day receiving hundreds of thousands of visual stimuli, and how do we process it? And we're still able to function in the world, and we're still able to kind of go about things. And so they designed a bunch of experiments and experiences to put people through in the 1800s to figure out like, how can we take in all this visual information? How does our brains work? And what's really cool is that since the 1800s, other psychologists and perception scientists and neuroscientists have built upon the work of the Gestalt principles with different kind of experimentation. As more technology has advanced, how we can actually look at what's going on in our brains as we're visually seeing information and processing it, that aligns with these principles that were established in the 1800s by just kind of observing how people do things through pretty basic elementary experiments. And so this is what's at play for us and our students, for all of us as we are working with data. And I just kind of I'm just going to give you like a little quick primer, and then I'll go back to like showing some examples, because this is what we can leverage to help our students. So the proximity principle is that most of us see initially a box of 9 yellow dots and then 2 triangles of 3 yellow dots rather than 15 yellow dots together. Because things that are closer to each other, we sort of group together. Sorry, one key thing I should say is that what they determined is that our eye, as it's processing visual information, groups it before it gets back to our brain, and our brain is able to process, is that grouping relevant, or what actually am I looking at? Because our eye isn't doing any of the cognition, it's actually our brain that's doing the cognition. But as our eye is sending that information back to our brain, we group things. So we group it into like a group of like a square group and 2 triangular groups, as opposed to just lots of yellow dots. The closure principle is that many of us see this as a 6-sided shape with a dotted line, as opposed to lots of individual dots, like dashes just all over the place. We sort of naturally close that in to be like, oh, well, that must be a thing. Similarity is a really strong one, like proximity, and that many of us see a blue group and a yellow group. And it sort of trumps the proximity. Like we see the proximity, but we also really see the blue and the yellow group. Many of us love to put things in order. So Maisie, when you were like, but they're alphabetized, why does it matter which way the students are organized? You know, those kids, those players are organized. Because we like to put things like in order. We like to make it sort of continuous. Like, well, wouldn't it be nice if just all those bars decreased over time? Or like, wouldn't that be, you know, helpful as we're thinking about it? Who knows if it's actually relevant to what we're looking at. Enclosure is that many of us see a group or would talk about like, well, there's a group inside the box, enclosed in the box, and a group outside the box. Who knows if that box is relevant? Connection is another really strong one for many of us. Welcome line graphs. In that many of us see 2 groups of 3 as opposed to a group of 4 dots and a group of 2 squares. It's just sort of the initial thing of what we're initially seeing out of the gate. Common fate plays a huge role in middle school and high school science, and actually even elementary, sorry, not science, making sense of data. Of many of us see kind of a group down here and a group up here. That like those things that are together, and they're sort of, we ascribe a like, oh, they're going together. They have this common fate of what's going to happen to them. And then finally, another one that has some relevance to the data visualizations is this figure and ground. So many of us see that there are 3 dots in front of the blue rectangle, as opposed to 3 dots enclosed by. We see this as sort of, well, that's in the foreground versus the background. Now, why have I tried to do like a quick Kristen version of psychology? Well, because it comes into play when we're looking at data visualizations. We are literally visualizing the data. Those of us that are visually able and looking at the visualizations, we are visualizing it. You don't need to know anything about baseball to notice that something happened in 2021 that was really different. And why? What is part of how your brain picked up on that really quickly? Well, it's continuity, because it went down and it differed from all these others, and the dots are connected. And so before your brain could even process that we were looking at different months of the season, and there's the, you know, RPM and all the different things that are happening in this visualization, what it's actually about, your eye was sending that information back to your brain in ways that were already grouped. Now, in this instance, it's great. It works to our advantage to be able to make sense of it. We can use this to our advantage for our students. So let's go back to the Mauna Loa that Stacy was just talking about, of how it relates to what she was thinking about. So right now, as we're just looking at the dots, we've got common fate going on. We kind of see these dots going together. It's on that cyclical pattern. We could use enclosure. We could circle in different parts of the graph that we want our students to pay attention to, or we could ask them to circle in sort of the different parts of the graph. That now we have two visual cues that are coming into our students' eye that their eyes are picking up on as they're processing what they're looking at. Or we could put a line. We could just bisect a line. This is not a line of fit. This is just like super just creating a visual for our students to look at. Now we have three things that are going on for our students' eyes to look at, to pick up, to pay attention to when they're looking at those data. Similarly, the annotations I was showing earlier, that's what was showing up over here. Like the different layering of multiple Gestalt principles gives more visual cues for our learners as novices to pay attention to when they're making sense of what's going on, what's on the page of the data. Okay, so for those of you with older students who might actually be doing lines of fit through your data, which are awesome, and our students absolutely should be doing lines of fit as they get older. So a line of fit, what we've done is we're using connection. We've put a line through those points. It's why they really like the points when they're attached to the line. If you remember that Pew study we were talking about last month. We could put these sort of upper or lower bounds. Those of us that have gone through statistics might see these as confidence intervals. They're not. It actually has nothing to do with the data. We've just literally we've annotated lines on either side of the data. And so what has that done? That's gone from there's lots of white space and our eyes don't fully know where to go except looking at this line to, whoop. Okay, now look between these dotted lines. And we're pulling the eye in. We're giving that eye more visual cues on kind of what to pay attention to. And as I said, they can do this or you can do this, but what we're leveraging is how our eyes make sense of things to create opportunities to be like, I want to give you more things coming into your eyes that are going to get your eyes focused on the part of the data that I want you to be looking at and paying attention to. Okay, that was a lot. Thanks for going with me on my psychology. I tried to sort of create enough connections to kind of different kinds of visualizations that you might be using with your students. What I would love to do is create a space where you guys can go back into your breakout rooms, look at those graphs or that graph that you were originally looking at the beginning of our time together, and think about what Gestalt principles could be at play. Like, what is your eye picking up on? And what else could you add? Like if you were to add an annotation, if you were to add a line or a circle or a box or something that you could physically add onto the graph to help kick in another Gestalt principle, to kick in another like, okay, eyes, focus here. Because for our novices, thinking about all of the different things can be really hard. But if we layer on multiple ways through annotations that their eyes are going to be drawn in, then that's a helpful scaffold in for them as they're thinking about the data. What I've done is I've put the graph types again in the shared resource document. Where are we? Into the shared resource document. They are here on page 43. Catherine and Patricia, 41 and 42 are the like how we talk about data patterns with our younger students. For all of you, but just you guys are asking. So I've put these in. I'm going to open the breakout rooms, and what I'll do is I'll take a screen grab of all 8 of the Gestalt principles, and I'll put it down here at the bottom so that you guys can look at that and compare. But just sort of jump back in, talk to each other about what I was just saying about Gestalt principles, and give me a quick moment to do that screen grab. I was grabbing the elementary stuff before we jumped into this call, and then and think through like, what might be happening? Like what Gestalt principles are already here visually in the graph? And then what could you add to create that extra layer for a novice to help them see what you are seeing in the visualization? Does that make sense?
Yeah, Kristen, do you want all of us to look at all of the graphs or do you want us to just focus on the one?
Just focus on the one that
Okay.
you were looking at previously.
Okay.
And I think that, Carrie, were you with Janice and Stacy initially? Okay, great. I think the breakout rooms have held. So I'm going to open up the breakout rooms so you guys can jump in there. Andrea, who were you with, Catherine and Patricia?
Yes, I was.
Okay, great. Let me reassign you
Thank
so that
you.
you can jump back in with them. Okay, and I will take that copy. Welcome back, everyone. How did it go trying to distill that, like, oh, that can be like wrap your head around something really new and sort of different and apply it to a visualization you've already used? How are we feeling of like super excited? Like, I get it, but not really, to like, oh my goodness, Kristen, I'm so overwhelmed. What are you doing to us? It's 6:45 on a Monday. How are we doing, team? Okay. We've got some, okay. I would say when I first saw Gestalt, I was like, what are you doing to me? This is bonkers crazy. So I will share, this is a like, just sit with it. Do not teach your students Gestalt unless you are teaching a psychology class. Like, that is not at all what I was doing by sharing this. This is one of those things where I'm like, so this is why annotations of our graphs or thinking strategically about what we might want to highlight or how we highlight can really play to our advantage because of how our eyes and brains make sense of things. If this resonates for you and if you want to use it with your students, great. If you're super overwhelmed and you're like, I need to sit with this, but I could see some potential, great. If you're like, nope, this totally pushed me over the edge, don't worry. That's totally fine. Okay. I just wanted to share it out of like, this is what's going on as we all process information, data visually, is like our eyes are playing in. And so I wanted to kind of unpack a little bit like what's going on inside of our heads and our eyes that are layers as we're asking our students to make sense of data and describe and analyze what's on the page with data. Happy to talk more if folks have questions as we are moving through. Happy to stay on later or as we're all together in April in just a few short weeks, which is crazy to think that we are like already there in the school year. So this last piece, what I was trying to do is just give us like a little peek into like brain science and perception science of how things are actually going on inside of our brains and some strategies that we could use of like with strategically annotating or highlighting certain parts of the graphs either that we could do or our students could do. I loved the group looking at the Taylor Swift. I was seeing like making the error bars the same color as yes, no, like color coordinating to bring in that similarity is a great example of like just small changes that we can do that could have potentially a really big impact of drawing more of our students' eyes to the things that we are looking at or that we want them to look at in the data. Please notice here, it does not say you have to use the Gestalt principles. Okay. So what I want you all to do, what I'm asking that you do between now and April 1st is we're thinking about like, okay, so how do we apply this? How do we take this forward into our classrooms? Is consider, what I'm hoping is that you all have a lesson that has data included in it. If not, no worries. You can still do step 2. But if you do have a lesson that has data in it, that initial like gut check, do they know the pattern? So like determine what pattern is in that lesson coming up. And then what I'm asking you to do is do a do now or an exit ticket or a bell ringer or like something small that you can sort of find a spot for in your classes between now and April 1st, recognizing that time window has gotten even shorter because you also nicely adjusted for me. And that's related to that pattern and see what they know. How do they talk about the pattern? So get them to talk about the pattern. What are they seeing? What is it showing? really like what is on the page? How can they unpack that? And collect those student responses. So what we're actually interested in is like, do they jump right to interpretation? Do they try to guess what the meaning is? Do they try to like make something up, or do they come up with all sorts of crazy things? I love our students, but sometimes it's like kind of out of left field what they come up with. What we're trying to get is for them to get their thinking visible about what's physically on the page, what they're actually looking at in the graph. So how it relates to a lesson you already have is like, it can be content connected, or it can be totally a different content, but it's the same pattern. And in fact, sometimes that's even better, because then they're not trying to guess the content objective we're after, and we're just getting a sense of what they know, how they think about the pattern. You decide, but we're just trying to create a small instance where we can get them to make their thinking visible about how they see and talk about a pattern in the data on the page. And so then you want to kind of note what kinds of questions they might have or what things they're bringing up, and then upload them into your slides. So the link for that, just like in the past months, is in our shared resource document. So down here, sorry, scrolling through, down here at the bottom, each of you guys have slides with your names on them. I was putting them in as you guys were in your last breakout rooms. So I pulled over this session takeaway that we were just talking about, but then I pulled in like, so, you know, Catherine, these are your slides where you can put in like, what strategy are you using, examples of the student work, etc. And so that's what I'm asking, hoping that you'll be able to do between now and April 1st. Are there questions about what I'm asking you to do? Okay, great. I have one note of caution about Gestalt principles, and then I just want to make sure we're all on the same page for logistics for later in April to answer like what I can. So just a reminder that these Gestalt principles, like how our brain processes and makes sense of information, is going on all the time as we are going out in the world and making sense of data. And sometimes it can work against us. So, sorry, I should have given you a warning. We're looking at a visualization about gun deaths. I always forget to give that warning. So this is a visualization that was put together in 2014. And there has been a lot of research done about this visualization. What the vast majority of adults who saw this visualization read gun deaths in Florida, and then their eye dropped down here to this annotation of 2005, Florida enacted the Stand Your Ground law, and they see this dotted line going down. So the connection principle was jumping out for them as it went down. And they interpreted this graph to mean that the law passed and the number of gun deaths decreased in Florida. The problem is that, or the problem with that conclusion is that the y-axis is actually flipped. And so if we were to flip the y-axis as we are more sort of typically think about it, or if for like the line to go down, meaning that gun deaths have gone down, actually what we see is the law was passed and the number of gun deaths increased. Now, I share this as an example of when Gestalt can kind of get in our way. Because remember when I was saying with this Gestalt principles, our eye groups things before we even know what we're looking at. So before we even have a chance to look at the axis or pay attention to what the colors mean or different things like that in our visualization, our eye has sent information back to our brain. And we need to train our brain to pause and think, is that grouping actually helping me or is it leading me astray? I shared this example because this visualization was not what the visualizer was really intending to show, that the gun deaths increased after the law was passed. Because what they were pulling from was that, this is sort of morbid, sorry for the Monday evening, that more red meant more blood and therefore more lives lost. And so they were trying to show that there was more red and that was a problem. So they were not trying to manipulate what you took away from the visualization, but they kind of forgot about Gestalt principles as they were putting together this visualization. And therefore, many adults walked away with an inaccurate understanding of what happened in Florida. So this is just my like little warning of like, Gestalt can be really helpful. We can use it to our advantage. We can kind of think about it in terms of strategic highlighting and annotating. And it's also why it's really critical that we help our students stop and pause and think about what's going on in their graph. That graph was not intended for somebody to walk away with a different conclusion than reality. And yet still people walked away with a different conclusion than reality because of the Gestalt principles. So that's my like, sorry, it's kind of a morbid example, but I just wanted to share of like, just be mindful of like, as you're going about your day, like see what kinds of things you notice. See if you pick up on some of these Gestalt patterns, Gestalt principles as they might influence or impact what you're seeing as you're going through things. Okay. Central Oregon, I'll see you all in person on April 3rd and 4th. Oregon Coast, Annette and I will see you guys on April 14th and 15th. I think everybody's received emails from Kama and Tracy about different components, things like that. If you've not, let me know. The locations and times for the different days are in our resource document. So let me scroll down so that hopefully you guys can find them all there. If you have questions about travel or about logistical things, those should go to Tracy and Kama. But if you have questions of like, what are the timings of where we're going to need to be? That's here. Where are we going to need to be? That's here. And we will be adding more information in of the kinds of things that we'll need to do. You'll need to bring some sort of device that has your curriculum on it, and you will need to bring yourselves, and we are going to be co-constructing lessons together. So we'll have some activities that we do, but the vast majority of our time that we'll be together when we're in person will be co-constructing lessons that you guys can use throughout the rest of the school year. Hopefully, if not, we can design a lesson that you can use next year that applies some of these strategies and principles and components that we have been talking about across the last couple of months. Okay, that was a lot of me talking. Are there any questions about kind of generally what we're going to be doing when we are together in April? Yeah, Mickey.
Maisie and I were wondering, is the goal to create a collaborative lesson or unit where the math and science are working together, and that's why you have one of each of us from the school? Or are we just working together, but our lessons might be separate from each other?
Yeah, that's a great question. So we wanted you to come together from similar, like we were trying to have partners from the same schools because it's easier when you're not the only human who's trying to bring in new things into your work. And so the partner pairing component of the cohort was mostly for that camaraderie and that support during the cohort and moving on. We are pulling you all together to come in person for writing these lesson plans for a couple of reasons, rather than having be like, okay, go design a lesson and then share them out with us. Pulling us together to have that shared time in person creates a couple opportunities. So Mickey, if you and Maisie want to write a lesson plan together, great. Oftentimes in many schools, it's hard to get time where teachers can connect wall page during the day to be able to co-construct together. So that totally works if you want to do a math science. Or Mickey, you could partner with a science teacher at another school, which very rarely happens during the paid day when we're, when we're getting paid to be there, to design a science lesson together as someone who also teaches a science content area that's similar, and you could work together. Or if neither of those are exciting to you, you can come write your own lesson, Mickey, but you're in the room with lots of us that can help you find data sets, that can help you troubleshoot, think through how different pieces will go. We'll do a lot of sort of sharing with one another and getting feedback. So it's a bit of a choose your own adventure when we show up in the room, how you want to design your lesson. But we wanted to create opportunities for those different options. And so that's partially why we kind of have the cohort be mixed and bring you all together in person. Did that help answer your question, Mickey? Awesome. Other questions that folks have about those days in April? I recognize like Still pretty big picture, but I wanted to give you a little bit of a sense of like kind of where we're going and where we're headed with it. And we'll talk more on April 1st about it if you guys want. Happy to. Just wanted to kind of give you like, we're now a few weeks out. If we talked about this in November, then it can like get really overwhelming. So that's why I was sort of like, we'll wait till we're a little bit closer to the time. Okay. Not hearing any. I will just share life is in session. And so I've heard from a handful of you of like, I have this doctor's appointment or this thing. If you could just let us know if there's like a time on either day when you're not going to be able to be there in person, just so that we can have a sense of like head counts and different things like that. That's super helpful. Otherwise, thank you again so much for your flexibility of bumping to this Monday rather than last Tuesday. Super excited to see you all on the 1st, where we'll talk about, oh my goodness, what do your students actually know about those patterns? And then next month, getting to see you in person. Super excited to come up to Oregon for both of these 2 double days of lesson planning together. Thanks everyone. Have a good evening. Go eat some dinner, enjoy, or whatever you need to do. Good luck tomorrow at school. Thank you. Bye.